Welcome back to VTU e-Shikshana program on computer-aided engineering drawing. We are working for module 4, that is isometric projection. The part 1 of the isometric projection we dealt with how to draw isometric projection for simple solids, and also given orthographic projection how to sketch steps and related type of objects. Now we are working for isometric to orthographic. Suppose that you get a figure, isometric figure or isometric view, how to draw the orthographic views, the 2 views or 3 views as per the requirement. Now let me take a very interesting and a simple model. It's a common universal model taken by mechanical engineers to discuss the conversion of isometric to orthographic. You can see only one figure. I can generate number of figures on this, number of objects on this, just by making small changes. Now before going to these figures which are already worked out, drawn, now let me take L-shape object and let me take a square block and divide that into 2 equal halves. Okay, and take only this portion and attach here. That means this one I am going to keep it here. That becomes this. Now L-shape object, say this is 60 by 60 overall, this is 50 by 50, 50 square block I have take and then make equal halves diagonally and take this part, the lower part, and keep it here. It exactly fits into that. So naturally the object you get is L shape with web type. Okay, now what is the orthographic projection of that? You know very well that if you look from left, you are going to keep it on right profile plane, L shape. This is L shape. I have drawn this. And then if you look from this direction, this web wedge is only this one is visible because these lines are coinciding with each other. Next, that is side view. Front view is we have rectangle 60 by 60 say, and this is 20, this is 20, 20, 20. So 20, 20, 20, and this slope is represented by a rectangle. This is actually the apparent shape. Okay, suppose that I have a inclined surface like this. Now if you look from front, you will get apparent shape. That apparent shape is represented here. Okay, now what about top view? Top view is again a rectangle overall figure, and this top surface is represented here. And in front view, this surface is represented here. They can even name it. So for example, this is surface A, this is surface B. So top view you can see surface A, and front view you can see surface C. So this is surface C, inclined surface. You can see that in both top view and front view because it's common for both. Apparent shape. Now these two horizontal remaining surface after keeping the wedge you can see here, and these two you can see in this front view. That's all. Now if you want to draw the top and front views of any solid, you must keep the overall figure and then start working. Now as I said earlier, this is the way I worked. I have drawn L shape, say, then I have sketched this single line to represent this one, and then top and front views I got the overall figure as rectangle. This surface is available here and this surface is available, and then drawn lines. Then I am very particular about small modification and then familiarize you how to catch things, particularly to change asymmetric to orthographic. Let me go for small change here. I will change the web size, that is the size of the web. I will reduce 10 mm and here 10 mm and join this. Okay, and again visibility is this. Yes. What changes we are going to make here? So here in this case I reduced it by 10 and again I took backside on the horizontal surface 10 mm. Now what changes I have to make? So let us see that this 10 mm down here. So here I am going to draw This here is the blank. Now if you look from top view, again 10 mm. So this is the front and top view. What about side view? Side view also you are going to reduce it by 10, reduce it by join them. So that is what you have to do. So the side view is going to change by reduction. We can have projection or simply mark 10 mm. This is only the reference I am taking. So this is what the side view looks like. This is front view, this is top view. Okay. Now let us go on making changes and then convert the available front view, top view, side view, so that you get clear idea about how exactly you can convert the asymmetric to orthograph. Now what I do is I will retain the top one as this and reduce the top portion by 10. That's all. Webbed or wedge is going to be changed. Now what I do is I will change this here. Up to this I will extend. You will extend up to this. Okay. Now what changes you are going to make here? The front view, any changes? No, because this is retained as such, and even if you extend to the front edge, no change in the front view. There is very much change here because we have extended this wedge or web till the last point, that is front edge. Yeah. Yes. What about side view? Side view is again there is change. Here instead of this line, I am going to join 10 mm gap definitely, and this is going to join to the front edge, vertical edge. Now the front view, top view, side view. Let me verify. Here is the gap, definitely there is a gap, and from this end to this end it is joined. Again in top view you can see the surface gap you cannot realize here because this is the edge coinciding with this edge. It is simply vertical surface, it is simply line. Okay. Now I will change it to the top one I retain and then front I change. So here I remove and then here I try to join. So here is the new object. This is the new object. 10 mm, let it go inside as we have discussed earlier. And now let me change the existing figure. What exactly changes you need? That means you are going to have gap here in top view. Yes, 10 mm gap. This is 10 mm gap. And here you are going to reach the top edge with this web. What about this? Yes, definitely there is change. You are going to have this 10 mm gap until this last point, top point, you are going to have this edge. So again there is a gap definitely, and side view L shape with this web 10 mm before it will stop. Then in front view you can see throughout this cannot realize in front view, this is simply line because here there is a line, there is one more line, this gap, just simply a line, no changes. So definitely this is what the changes we can do. Now let me have some more changes, little special changes here. Extend the top face. Extend the top face by some value 10 mm and join this here. This is a different type of web. This is for supporting some machine components. Okay. This is another different solid now. What changes you make? You can easily catch the side view changes. Yes, side view definitely easy to make changes because you have extended this for 10 mm and then joined completely with this. Yes. Let me take this same plane, continues, and then again it will join, this point will join with the edge, front edge. Okay, this is the side view. What about top view? Any changes in top view? No, because the entire contour, it may be a rectangle or any contour, if it is perpendicular to VP, it is simply the horizontal one line, simple line, okay, regular line, no changes. And also the topmost edge is coinciding with this. But what about the top view? Again, top view, this wedge is going to continue up to this, but there is small change here because this completely single surface is different pattern. This line will not be available 10 mm front, and this is a single surface, and you are going to have this. It will touch this point. So let me review whether whatever we have drawn is correct. This special wedge continued up to 10 mm extra, then it will reach the front edge, top edge of the base reference, and then front view is this, complete the surface. Even though it is apparent shape, it is visible till this point, this edge, this edge. Yes. Now in top view, this contour is visible. It's a single surface, and from this point it will join the edge, front edge. So this is how you get the conversion of isometric to orthogonal. Again, let me take one more change. Okay, so let me utilize the given this one. Extend this front surface also like top one, the vertical surface. Here we extended the horizontal surface, now we will extend vertical surface. That's all. Yeah, it will be straight line. Yes. And visibility of these lines depends. Okay. Now, so as we did in the previous case, this contour is available here in top view. You can see the contour in top view. Fine. What about front view now? Same type of contour is available in front view also with 10 mm up. Okay. Then it will continue up to the top face. Irrespective of the contour, same line will work for that. Now, front and top views are over. Okay. Changes are over. Now, what about top view? For side view? Side view also, same type of thing is available here, that is extended for 10 mm, then join this with the existing one. So this contour is available here, 10 mm extended with the vertical surface, front vertical surface, and also 10 mm up with the front vertical surface of the base, then joined. Here is the front view, here is the top view. So front view contour here and top view contour here. That's all. Okay. Now let's go to small change again. Instead of maintaining both, we have retained the top one first and then extended up to this. Here now I retain this and then join this here. That's all. So we go for this changes. Reverse procedure. line is there, vertical lines. Now changes are this. Yes. Now what type of modification you have to do here? See, check, there is no contour here, it is just in top, it is just plain. I hope I have done the same here. Yeah, because this contour is not visualized here, it is simple surface and it starts from the front end of the vertical surface. Yes, but in case of front view, this contour is available. Whatever I did in the previous dashboard 1 case, same thing is repeated ulta. Now here is the change. I have to join this with this, that's all. You can go on making changes, small changes, so that you get different top and front views and side views. Let me realize this. This is again starting from this 10 mm above, fine. Okay, and from front view you can see this contour, and then this is the slope, rectangle, and in top you can see as though it is completely available up to this, but it stops here because of this vertical surface, single surface. It is coinciding, this contour is coinciding here, you cannot see. So this is how the changes can be made and do it. Finally, last change what I can make is go for a universal thing, that is a polynomial curve. So you can have this, let it follow a particular type of this one slope. What best we can do is can have a radius of particular this one, and then have center and then draw 2 arcs just for visualization. And this is a slope, curved slope of following some particular polynomial. Now this is just for visual explanation purpose, I make this dotted. This surface is curved surface. Now what is front view and top view here? Suppose that you take a cylinder, for example, and okay, you look at this, you get rectangle, that's all. Okay, even though it is curved, it is a rectangle. Front view is rectangle. Similarly, a curved surface which is following this one, it is like this, a curve is there, then you can see the front view or top view, both are having rectangle. So a curved surface is going to give rectangle again. It is the original figure what we have. Yes, this is curved surface, this is curved surface representation. It's going to end at a sharp edge. Okay, now what about side view? Side view is actually the whatever the curve you have created there. Okay, so let me assume this the curve. Okay, it is going to join this. So this is again defined, a particular definition of this will be given. So this is how we can have number of changes and then work out orthographic to isometric. So let me have some more solids for understanding purpose and workout. Simple solids. Okay, let me have the block, rectangular block, say. Yes. Now it may have a slot, square slot, square slot. Okay. Or rectangular slot, whatever. Okay. The visibility is this. Yes. Yes. This is. That depends on the height. Actually, this is the vertical surface available here. This line is not available, it's thin. Again, this is thin. What is front view? Front view is just line like this. Okay, and then top is we have 4 lines totally. Yes, 4 lines. Some dimension, say this is 60, 20, 20 and this is 30 say. So dimensions are there. Suppose that I try to block this at this point. Say this is total 50, dimension is 50. At a distance of 35, I close this channel type. I'll make this way. Okay. This is a single surface now. Okay, single surface. Okay. So what is front view? What is top view? So small changes. This is the line representing this edge because black we have blacked that, and also in top view, say for a distance of 35 I have taken, and 15 is left. Yes, this one is not there. These lines. So as usual, you have this till end. Same pattern is available. Okay, so this is how we can go on changing. So for example, this is okay, 30. This is also 20. Now I will make small changes here. For a distance of 7 each, I will make tapered. Okay. So what best we do is keep this line like this, and how to get this? This one is not there. How to get this line parallel to this? You have to draw till it reaches this. That's all. Inside you cannot see. So here pattern will change. This will not be there. Is available. And what about top view? 2 more lines will be added to represent these edges. Yes, 2 lines added symmetrically. This is symmetrical about this. So like this, go on changing the shapes and also the pattern, dimensions, etc. Now let us discuss same thing in computer. I have some more added to discuss the isometric to orthographic. Okay. So we have learned how to draw isometric projection of simple solids, prisms, pyramids, blocks, and also frustum of cone, frustum of pyramids, etc. And also some of the specific problems. Now let me discuss the isometric view to orthographic. How to convert isometric view to orthographic. Sometimes we need that type of document also. So let me take a simple machine part. Here I have a simple machine part like this. This is consists of 2 parts. One is L-shaped object, and also this is the half of the square block, you can say. That I will explain here. Let me consider a square block and cut into 2 equal halves diagonally like this. So now you will get 2 parts here. So let me keep this one on L shape. So then you will get finally this particular object. So how exactly we can do? Now the software can facilitate us to do this. Let me have this and this, just like combination of solids. We have been working combination of solids. How to work out, I will tell you. Now let me select this, assume that already we have done, and take midpoint of this and then move. Okay, we take this midpoint of this, move to this point and say join with midpoint. That's all. Now you will get this object. This is how you get some of the specific objects combined and then becomes the machine parts or some supporting items like that. Now the thing is, I have taken the square block and cut into 2 equal halves and then joined this and got this one. Now how to draw orthographic projection of this particular object. Now we have the same thing which is colored just for visualization and also easy understanding. Now this is L shape. Okay, you can see that, assume that this is front view, this one is top view, and this is left view on right side. Now this is L shape, light blue color surface represents the L shape. Then this is web. Okay, this color is identified from starting from this end to this end. Yes, this is like triangle. Looks like triangle. Yes, it is actually triangle shape. Now, what about front view? Front views, see, this one is yellow color front surface of L-shaped object, and then little bit regular blue color surfaces are visible. These two surfaces are visible in front view. That I have identified. And also the apparent shape of this is available here. If you look from top, same view will be available because it is of same type. So here is the shape, green color, and again these two are blue color items, and this is as usual common to front view, top view. So this is how you draw the orthographic projection. It is overall say 60 by 60. Okay, 60 by 65, this is 60, 20, 20 each. So this is 20, 20, 20 each. Height is 65. The breadth is also, this one is 60 and this is 65. Here you can see 65, 60. This is how you can draw the isometric to orthographic. Now let me make small changes so that you can understand better. Let me reduce the height of this web by 10 mm, here also 10 mm. I reduce this to smaller size. So this is how you get the front view, top view and side view of this one. If you look from side, L shape, and then this is triangle type, definitely. Starting from this end to this end, it appears as though it is complete, but width is small, yes, for 20 mm. Now let me reduce this to smaller one. See, 10 mm down and this is 10 mm back. So in front view, what is the change with respect to this? Here you have to reduce by 10 and you have to reduce by 10, and again you have to take this to down 10 mm, this is back side. So here is the orthographic projection. So if you look from left side, you get L shape, 10 mm down, yes, this is again 10 mm back side. You get again triangle type. So how come this line and this line are same here? Because it is same plane. That's why it looks like single line. It is on the same surface. Again, if you look from top, again you will get the rectangle because apparent shape of this. If you look from both directions, you will get same type. See, similar views, ulta, that's all. Okay. Now, the thing is, you have to be very careful regarding the dimensions and also the correctness of the views. So for example, if you draw lines like this, then it is wrong. So sometimes it happens. Now, after this, let me go for further change. Now let me retain this up to the top corner and let it be gap. That means from this end to this end, let me join again this end to this. No, there is no gap here. The gap retain here. So exactly it looks like. See. Otherwise, other way around, you let me retain, that also is there. You retain here and gap here. Now look from top. Any changes you have to make? Definitely yes, because this particular point indicates starting point is this and ending, there is no gap here in top view. Up to this it will extend. At the same time here, it is same. No changes because gap is there. Here I have to draw a line. So there will be some confusion, but be specific, review twice. So select this and make it dark. Yes. So this is how we change. Let us see whether it is correct now. check this starting from this point. Yeah, I am reaching the front end edge, top edge, front end top edge, and this is up to the front end top edge. There is a gap, yes. So you can realize what exactly the correctness. See, the figure will be like this. That's what we have done. Okay. So any changes, you make it. So there will be some confusion, definitely. We thought that it's different. Now, let me have gap here and go up to this next figure. See, this one is extended up to the top edge and there will be gap here. Whatever we did earlier, it is ulta. Okay. Now, what changes you have to make? Yes, there will be definitely change in the front view because there is no gap here. It is completely up to the top edge. So, keep this edge up to that. Now, extend up to the next point. Yes. Front view ready. Then what about top view? Yes. Let us retain the same because there is gap. And what about here? We have to catch this till we reach the top point. We should not stop here. Let it be here only because there is a gap. 10 mm, 10 mm gap. Here you have to change it. So let me have the same reference and go up to this. Okay. So then delete this. Now it's okay. Now there is a gap in front and there is no gap at the top. Now dark this. So this is, let us review front view. You can see the surface, yes, and this one is inclined surface. Whether there is a gap or not, it looks like this apparent shape rectangle only, as though it is in front or back side. It is same thing because this surface is a line again. Now from top view there is a gap definitely. Okay, so this is top and front views. Now let us check the answer. Yes, there is a gap. There is extension up to this, and we have front view complete rectangle covered by the top end and this edge. So this is how you can draw isometric to orthographic. Then let us have some more changes. Let us extend the top face only in the same plane for 10 mm in the T shape and see what happens. See, I have extended this. It's a triangular web. Now it has become trapezium web. Okay, so I have extended the same plane only for this value, that is 20 mm for 10 mm. 20 mm with 10 mm extension. Now the top view is correct. So that is what I have. This contour you can see from top, and this one is apparent shape. You get rectangle till the end of the edge. Yes, top view is correct. Now what about front view? Front view, any change? No change in front view because irrespective of the profile, this is the same plane. You can see only line. There is no surface. Only in top you can see the profile, and this line, these two lines are points only. Okay, but there must be some change in the side view. What about that? See, you have to extend in the same plane 10 mm and bring it this person. So join this point with this. So here we have to change this. So now what I do is I will go up to this 10 mm front, 10 mm. Then in case of regular projection, you can project from this through 45-degree line. You need not have to measure. Just for explanation purpose, I am doing it. If it is regular projection with 45-degree and all, you can just project this. Now, I have to retain this profile and you have to remove this. So, dark these two. Yes, we got the required this one. top and front views and side views. So this one is extended up to 10 mm, and here this looks same, no change here, because in respect to the contour you will get line. Now let us see the answer. Yes, correct. Now instead of extension of the top face of the L-shaped object, let me go up with this T-shape, inverted T-shape with 10 mm up, and keep this like this only. Okay, now see, I have done this extension, same plane, and front view, you can see the profile or contour, whatever you have created here, and this is true shape, true shape. Actually, this is apparent shape. If you look from perpendicular to it, you will get it. But here we are looking from front. So naturally, this is front view. There is any change in the top view? No change in top view, because this is completely a line reference. Okay. This one, line. Again, this is line reference. No change here. Irrespective of the contour, you can see only line. Here, as usual, you get the rectangle here and one more rectangle representing the slope. Whether it is up to this edge or above, 20 mm above or 10 mm above, one and the same. Because it's all coinciding. These lines are all coinciding. That's why you will get same thing. So this is same. Top view is same thing, and this contour you get in the front view. And what about this? Definitely there is change here. Okay, earlier we had 10 mm extended here. Here I have to extend 10 mm here, and then join with this and this. So this is how you do it. Okay. Now let me extend this up to 10 mm. So already we have this, so you can just use alignment indicator. You not measure 10 mm, and then see, this is what you have to do. This refers to 10 mm. So dark this. The only thing is you must have some imagination. So it's always good imagination, and also converting the orthographic to isometric is very important majority of the time, that you realize the actual solids, objects, shapes. So let us realize what exactly. See, this surface is represented by rectangle. The whatever below you cannot see, only this portion you can see from the top. Yes, this is rectangle, as in the first figure only, basic solid. Then here front view, contour is there, and the slope surface is represented by rectangle again, apparent shape, and these two surfaces are here. Then this extended surface is represented here. Same thing. This you have to join. This line is representing this. So this is how you realize and then work out isometric to orthographic. See, this is the answer. Next, let me extend in the lower surface and also the top surface, both like this. Here I have done one each time. Now let me do in a given time both, extend here also and see how exactly it is. See, I have extended the top surface also by 10 mm for 20 mm width. Again, I have extended up the base block by 10 mm for width of 20 mm, that is mid width, web. I am changing only web size, web shape, that's all. Now you get contour. See, this contour is available in the top view, yes. And the surface is available in the top view, yes. You cannot see this in top view. Similarly, front view you can see this, and also this you cannot see this because it looks like line for you. Suppose if I keep a sheet parallel to the ground, what is front view? It's a line. So same thing here, and you have to extend in top as well as base. So you have this, extend in the top as well as in the front surface. So this is the front view, this is top view. See the similarity, both are same type. Even in the basic figure we had same thing. Okay, see, same. Here side view is different. So like that. So if you have the symmetry about this line and also the similarity in the both wings, vertical as well as horizontal, then you will get. So this is how you get the isometric to orthographic. Now let me have simple solids and go for visualization. What exactly the changes one can make. Now let us assume the same thing. Instead of some contour, let me assume a curved surface. It follows some polynomial. Okay, let me not give particular. Assume some value so that it's continuous curved surface, polynomial type. Okay, it can be a semicircle, quarter circle of the circle also. Okay, or any radius starting from this point to this point, continuous. In this case, it resembles very first figure, as though you have a triangular web joining from this point to this point, even though it is curved, it is moved inside. Okay. So it looks like rectangle only. You can see the curve. It can be a part of quarter portion of the circle for a particular radius. Okay, actually this is 50-50. So 50 radius, draw a circle from this to this. You can take these two as centers, draw this one. That is another corner of the square. If you assume, then draw quarter portion of the circle. That becomes also curved profile. Now these two are the top and front views, and this is side view. Next comes the simple model. So channel type, square channel type. This sometimes it is used in some machine shop, some machineries. Okay, part as a part. Now, what is front view? Front view is U shape. See, front view is U shape with a specific dimension 70 by 40, and here is 20-20. Actually, 20-20, 40 minus 30. So this is 30. Totally is 30. Then here, so height maybe 40 is there. You can assume 20. If nothing is given, you can assume half of it. Otherwise, you can assume accordingly. So it looks like half. So assume that it is 20. Now 20 mm down, 20 mm down, and this. Now what are the lines to be darkened? And what is top view? Top view, you will get this surface, both either type surface, and this one darkened surface. This you cannot see in top view. Okay, so you cannot see, but you can see this in top view. So that is what available. Now you get total number of lines 1, 2, 3, 4, and this line is coinciding with the top line because it is vertical. Any vertical line, if you project it, vertical surface, vertical plane surface, if you draw a projection, always you get a line as the projection. So here it is vertical surface, definitely this is line. Now to dark, how to complete this? So let us start working. I have done some sketches, wireframe sketches. Let us dark visibility, what exactly this. Now select the lines. Now this is not completely visible because there is a through gap. This is not available. So what I do is I will trim this. I will trim this. Now start working. So these lines are visible. Let us select and dark. That's better. Okay. Now select these lines. All boundary lines are dark for this front view. Okay. So let me make little thick so that you can understand better. Yes, this one is missing. Yes, this is what the front view. Actually, it should be 0.5. For explanation purpose, I have made it little more thick so that you can understand better. Now, what about this? all these lines are dark because this line, even though there is a channel type, these edges are available and visible. Okay, as though it is at the top. Whether it is at the top or bottom, one and the same is visible. If you look from top, this shape, this profile is a line. Okay, see, it's a line. Definitely there is a break, corner is there. Okay, so you have to dark all the lines, all these lines. Okay, so dark this line, dark this line, this. All edges are visible. Here there is some problem, I will tell you. So for this, since for the projections I have taken the same line, what I have to do is I have to, use split and do it. Okay. Let me split and do it first. Otherwise you can remove also, no problem. Yes. Now what all will be selected? Yeah, this is selected, this is selected, this is selected, this also selected, this also selected. These two becomes different entities, separate entities. So now the requirement is dark line. Yes, see. So this should be 0.5 in your case. Okay. Let me take next object. Let me block this. Say for example, here for a width of length of 50, I have through channel, square type. Now let me block this at a distance of 25 mm and close at 25 before 25 mm. I mean, how it will say this, how you dimension, that is also very important. Whenever you get the isometric dimensions are given, how to dimension? See 70, here 20 20, and this is not to be dimensioned because it is understood because of symmetry. 20 20, 40 70 minus 40, it is 30. Again height 20, then this is 40. This is only dimension you need here. So next object is this. I have blocked it. Okay. So this one I added. This portion I have added for the total channel. This portion. Oh, it looks like when compared to the previous this one. See, there is no line here. Okay, but what about this? Here there is very much line. Now I have trimmed there, but here you cannot trim because there is existence of the surface at that height. Solid is there. So naturally all these lines are dark. So what I do is I will select the dark line and then trace it one by one. The problem is split and all you have to do otherwise. Now, so boundary lines are there. Boundary lines are available. Yes. Complete boundary is available. And this is like a pocket. Yes. This is the front view. When compared to the previous figure, there is a gap because there is fully gap, no solid, nothing is there. So here we have the solid and also the corresponding surface represented as edge and also surface. This line. Next, what about this? Here there will be one more line added and this line will not extend till the end. It will stop before some value, say 10 mm or 20 mm, 15 mm, whatever. Let me see the dimension. So it is for 15 mm we have stopped. So this is 15 mm. Now I have to dark this lines carefully. Boundary completely visible. So it is same as previous one, but there is one more line added. There will be gap here. Okay, no lines. So always you prefer end points, end points. So this is how you can draw isometric to orthographic. Simple solids I have taken so that sequentially, progressively you can develop to get the complicated one. Now, same object I have taken, but I have widened the top portion of the area. It is like a trapezium shape channel. Okay, in irrigation we say channels. This type of channels are available. And also in some industrial applications, in some of the theories and practical events they use it. Now see, the front surface is, see, it starts from this, again it runs here, slope, again it will go up and then come down. Here we should know the dimension. Say this is 15, 15 and this is 20 and 10 gap. From this point to this point, vertical horizontal height is 10 either side. So this is 10, this is 20, 20, this is 20. So accordingly you draw this. Then what are the lines which are to be retained? Now what about this line? This line to be removed because nothing is there. If I block it, definitely as the previous case we have to show this. Let us see how exactly you do. Now let me trim this, otherwise it dark that also. Okay, so this will not be there. In top view, how many lines you get? 1, 2, 3, one side, another side also 1, 2, 3. Unlike 2 lines only in the previous case, because it is a slope, it is a clear-cut edge here. Okay, 1, 2, 3. Otherwise here there is a vertical surface. Here it is slope. Definitely you can see both the lines. See, here also you can see, here also. So these 2 lines. Now let me complete the front view and top view. So start with this boundary, this profile as per the dimensions given. Okay. Now all these lines are visible. Okay, 1, 2, 3, 4, 5, 6. So what you do is you try to dark all these. Okay, now I hope block will work. Let's see. Yeah, so all these lines should be taken. If all lines to be identified, that's why I have removed the necessary lines and then make it dark. 0.5 in your case. Now for explanation purpose I am doing this job. Yes, for clarity. Now next, what exactly the dimensioning pattern? Yes, minimum dimensioning you have to do 15, 15, this is 20 and 20 is the height. Okay, total height of the object is 40 and length of the object is 50. Throughout 50 mm, same pattern. Yeah, this is the front and back. Throughout 50 mm, same pattern. So naturally, this is how you convert the orthographic into isometric. So I have colored it in fact. See, this one and these 2 are one color. That in top view you can see. Okay, you cannot see any of the colors which I have shown here in front view. They coincide with these lines. Okay, so this is the interesting part of this. Now let me block at certain distance, say 25 mm or 20 mm or 15 mm. Now same type of augmentation here. This line is retained. This line cannot be removed because that is the information. The surface is retained and also you should have a gap here. Okay, so the thing is you have to trim this, that's all. So this is how you get. So dark this. Anything else, let me check. So this surface, yes, and exactly same front surface is available in the back. That's all. Now you try to block it and then torque. That's all. Entire thing is actually in case of projections you must show the projection sign and all, but here only for visualization and also the explanation I am doing this job can do it. So how you do it? That is with 0.5 or 0.7 you have to do this job. See, this is what you have to do. Use 0.5 as thickness and then do it. Dimensioning, minimum dimensioning you have to do like this. So here in the previous case I have 15, 15 I have given. Now I have given 40. So total is 70. Definitely 70 minus 40 is 15, 30, 15, 15. Symmetrical. Either way you can do. Okay. So that all depends on the type of problem we have. So this is again one more thing. Colored it. Now in previous case I have through hole, through channel. Here I have blocked. Now that is represented by green color, dark green. So parrot green. See, you can see in front view only parrot green, that particular slot, and also this white color front surface. Yes. And in top view, you cannot see this parrot green. You can see only these two colors. Either side the rectangles and then sloped rectangles and then upper and length shapes, and this is true shape. So this is again best example to realize the isometric to orthographic and the respective visible edges, and you are not working for invisible edges, and I am not also including any invisible edges right now. Okay, so let me have a circular surface, curved surface, particularly semicircular cross section, and instead of some trapezium or square or rectangle type, now I have semicircle cross section. Now what about front view here? Again, as I told you earlier, this particular line from starting from this point to this point will not be there because you have a through slot there. So again, trim this, and also you have 4 lines only because it is curved surface, no edges, no corners. So here one line, number 2, 3, 4. The only requirement is just to say you have curved particularly circular part of circular circle, you have to represent axis, that is must. Otherwise one may not be realized. Say people think that it is rectangle or square. Okay, but anyway there is another view is given, and you can also expect the people to give this, see, radius 20. So this should be identified. Then definitely one can say this is semicircular or circular slot here in top view. Now how to complete? Now what I do is I trim the unnecessary lines, protection lines, and this line. Now that's all. You dark this, you get the thing. Now you see this axis representation. It may go beyond this length, no problem. Better you stick within that, otherwise little bit beyond, no problem. Now this is the curved surface that is exactly semicircle of 20 mm radius, and these 4 lines are represented for this flat surface. This is curved. This is curved surface. This colored one, curved surface, and this is flat surface, and this is as usual rectangle. Now the thing is, just for visualization purpose, the colored one you can see in top view. Okay, in front view only you can see this surface. Only this. Assume that this is white color. You can see this. Okay. So this is how you dimension. So 70, 40, and only radius. Nothing is required. Here if it is 20, 20, this covers 40. 70 means it is 15, 15. So one has to understand like that. Now let me block it again. So this is very good exercise one can do. So you can also refer to N.D. Butt book, Engineering Drawing. He has given lot many figures, like simple figures and also a little bit complicated, and then give an answer also. one can really understand what exactly the isometric to orthographic and orthographic to isometric. Here is the line reference. Here I have to retain this line because this block is, I blocked it here, and this is flat surface represented by line. Not that we are representing this edge, we are representing the entire surface. The surface here, okay, it is not visible. U shape here. This. Now, in top view, this line is added, okay, and these two are retained. So let me do that for the purpose. So I have to remove this. This is gap between this. Now I have to take out this. Sorry. Yes. Yeah. That's all. Inverted U type. Then this is the front surface, curve it, and this line is very much available. So this is how you draw the orthograph. See this line. In case of through channel, this line is not there. So there are maybe many other things to discuss. This one is is visible in front view, that is like blue color surface, and in top view you can see the curved surface. This is vertical surface, this is plane surface, this is curved surface in top view. You cannot see any curved surface in front view. Okay, that's only the line you can say, curved line you can see, not the surface. So in coming days, in coming sessions, we are going to discuss some more combination of solids, little bit special items like a cylinder is horizontally placed on a hexagon and other things. Now already I have discussed, just let's through this. This is the step, and corresponding front view, top view will be given here. This is only making I have done. See, this is the steps, and this is front view, top view. How you convert this L shape here, not L shape, it is step, and correspondingly you draw this first and then project either side through 45-degree line, or simply take the width and this distance. Suppose this is 20, 20, 20, and this is 15. Here is the 15, here 20. So draw two parallel lines vertically, then that gets you, along with the side view you get the front view, and below that you get top view. That you know how to draw the top and front views. Again, I have one more already discussed. I have blocked it. Actually, through is not there. I blocked it. How to do it? And I have told you earlier. Now let me show final front and top views. This is the original one, and this is added. Yes, because of this extra solid, and instead of 80, I have taken only 50, and remaining 30 or 25 will be the solid portion. No steps further. So here also same thing. Here you can see L shape reversed. Again here you get L shape in this case. And these are the two top surfaces you can see in top view. And these are the two front surfaces you can see in front view. That's all. Okay, so this is how you do it. Now finally I have this. I also discussed how to draw orthographic isometric projection, taking this as a problem. Now I am doing reverse. Here are the blocks, rectangular blocks, kept one above the other, and taking the rear end surfaces are coinciding each other into on par with one surface. Here, this one. So the top and front views are like this. See, the rear end surfaces are coinciding, and here the side view, it looks like step like only. Okay, but in steps there is no line because there is no surface available. You can see the steps here, there is no line here in between. Here, because the surfaces are available, smaller ones are taken from this to end, this end, there is a surface. Definitely that is represented by a line. Okay, so the surface is represented by line. So anyway, once you start working, you get all the details. So this is how you can have orthographic to isometric to orthographic. Now we have discussed isometric to orthographic. Some more typical problems we will discuss in coming sessions.